Hello students, welcome to Misostudy and welcome to my class. Today we are going to discuss few questions from the chapter equilibrium, then we'll move towards the chapter redox, then hydrogen and S block element. We'll try to cover maximum number of questions in this lecture, and what I'm going to discuss that physical chemistry is completely calculative type, inorganic chemistry theory type, but I have taken the question slight different. I have taken the question that contains calculative part also. In hydrogen and its compound, one topic that is hydrogen peroxide. Hydrogen peroxide, that is, it acts as an oxidizing and reducing agent. So there is the involvement of volumetric analysis. So I have picked such questions which are completely calculative, not theory part, for hydrogen and its compound. But for S block element, I have taken complete theory. Is it clear? So let's start the question answer round and we'll try to solve maximum number of questions. Is it clear? Now read the question carefully. What is given here? That is, calculate the percent ionization of 0.20 molar solution of hydrocyanic acid. Percentage ionization you have to find, that is ionization, percentage ionization, okay, of 0.20 molar solution of hydrocyanic acid. That is, molarity is equal to 0.20 molar. It is given here, yes, of hydrocyanic acid, HCN. It will dissociate like this, H plus and Cn minus. Okay. Now Ka for HCN is 4.9 into 10 to the power minus 10. Now when T is equal to 0, that is 0.20 molar, 0 and 0. When T is equal to T equilibrium 0.20 minus alpha, then, or you can write like this, better to put like this, 0.20 minus x and x and x. Clear? Yes sir. Now what will happen in this case? Ka will be equal to H plus concentration into Cn minus concentration upon HCN. Is it clear? Now what is the value of Ka? That is 4.9 into 10 to the power minus 10, or you can write like this, that is x into x upon 0.20 minus x. Clear? Yes sir. Or you can write like this, that is x square, clear, upon 0.20. okay. So 4.9 into 10 to the power minus 10 into 0.20 is equal to x square, or x is equal to root under 4.9 into 10 to the power minus 10 into 0.20. You will get the value of x. Now convert it into percentage ionization. Clear, my friend? Yes. One more thing. Sometimes we do not apply this method. It can be written like this. Look at, when T is equal to 0, that is C 0 0. Okay. When T is equal to T equilibrium, it can be written like this, C minus C alpha and C alpha. This is the best one in case of ionic equilibrium. Okay. So here is C. C is what? 0.20, 1 minus alpha, then 0.20 alpha and 0.20 alpha. This is the thing. Now Ka is equal to C square alpha square. Is it clear? C alpha into C alpha upon C 1 minus alpha, or C and C cancel, that is C alpha square then 1 minus alpha. Am I right? Yes sir, you are absolutely right. This is the best one. Now 1 minus alpha, that is C1 minus alpha. Now K is equal to 4.9 into 10 to the power minus 10 is equal to 0.20 into alpha square upon 1 minus alpha. You have to find the value of alpha by solving the things, or sometimes it can be written like, if it is weak, then 1 minus alpha is equal to 1. So what we are getting, that is 4.9 into 10 to the power minus 10 equal to C alpha square. This is the best one to find the value of alpha. So put like this, not 1 0 0, put like this, that is C minus C alpha equal to C alpha this is. But in case of chemical equilibrium where not such involvement of acid base and salt, then we will write 1 0 0 1 minus x. So in this case we will apply this one, and now you can easily find the value of alpha. So this is the method to solve this kind of question. This is an integer type of question. Clear? Now you can solve? Yes, sir. Now I am going to rub this part. Now question number 33. In the ionic reaction, this is a question from redox reaction. In the ionic reaction, you have to balance the reaction. This is a question from previous year comparative examination. Now how to balance such kind of reaction? Better to use hit and trial method. Apply apply this answer option and check which one is completely fitted. Here, complete fit here. Now I am here writing, that is XCS3 CH2OH. Is it clear to you? Plus YI2 plus ZOH minus. That gives you CHI3 plus HCOO minus plus I minus plus H2O. Again I am repeating, that is XCS3 CH2OH YI2 plus ZOH minus CHI3 plus HCOO minus plus I minus plus H2O. Now I am putting option number 1 in the given equation. X is equal to 1, Y is equal to 4 and Z is equal to 6. Clear? Yes, sir. Now put what will happen in this case, that is 1 CS3 CH2OH plus 4I2 plus 6OH minus. Clear? Yes, sir. It gives you CHI3 HCOO minus, then I minus plus H2O. Now check the things. Carbon 2 times, yes, carbon 2 times, hydrogen 3 2 5 1 6 and 6 6 12 times. Okay, check hydrogen here 1 and 2 2 2 4. If I put here 5, then 5 to 10 and 2 12. Complete? Yes. Now put oxygen. Oxygen 6 1 7 times. We have oxygen 5 to 7. Completely balanced. Now iodine 4 to the 8. If I put here 5, then completely balanced. So we do not need to check another option B, C and D. We have got the correct option, that is A is the correct option, because there is only one option correct. Again I am repeating, for this question A is the correct option. Now I am going to rub this part and let's move to the next question. Next question is question number 34. What is question number 34? Yes. I have taken this question from the chapter hydrogen and its compound. As I told you, hydrogen and its compound belong to the inorganic chemistry theory part, but I have taken some calculative part. I have taken some calculative type questions, so that it covers volumetric analysis also. Now, a 5 centimeter cube solution of H2O2. Again I am repeating, it is given here a 5 centimeter cube solution of H2O2 liberate 0.508 gram of iodine, okay, from acidified Ki solution. That is the reaction between H2O2 and Ki. It gives you, that is KOH plus I2. Again I am repeating, it gives you KOH plus I2. Clear? Now balance the reaction. I2 2 times, put here 2, put here 2. Now check. Hydrogen 2 times, oxygen 2 times, potassium 2 times, and iodine 2 times. Is it clear, my friend? Yes. Now what is given? A 5 centimeter cube solution of H2O2. 5 centimeter cube, that is 5 ml. Okay, liberate 0.508 gram of iodine from acidified Ki solution. Calculate the strength of H2O2 solution in terms of volume strength. We have to find the volume strength. Clear? Yes. We know volume strength is equal to normality multiplied by 5.4. Clear to you? Yes. 5.4 into normality, or equal to 11.2 into molarity. Whatever you want, you can apply the formula. Either find normality or find molarity. Now for this question we have to first we have to find the molarity. Now what is given here? Look at the question. It is given that is 1 mole, or you can write this 1 mole iodine, that is 254 gram of iodine require 1 mole of H2O2. Clear to you? By the general equation. Now we have only 0.508 gram iodine require what? That is 1 into 0.508 upon 254 mole of H2O2. Again I am repeating, that is 1 mole of I2. 1 mole of I2 require 1 mole of H2O2. That is 254 gram of iodine require 1 mole of H2O2. So 0.508 gram of I2 require 1 into 0.508 mole of H2O2. Clear? It will be around the value of 2 into 10 to the power minus 3 mole of H2O2. Still, this is a memory based data. You have to solve the calculation part. Clear? Now we have got the number of moles of H2O2. Now what is the formula of molarity? Molarity is equal to number of moles upon volume in ml multiplied by 1000. Number of moles 2 into 10 to the power minus 3 upon volume is 5 multiplied by 1000. That is 5 to the 10, that is 200. Okay, then 2 to the 4. Is it clear to you? Then 4 into 10 to the power minus 1. Is it clear? That is 0.4. Molarity is equal to 0.4. We have again calculate 2 to the 4, 10 to the power 2, 10 to the power minus 1, that is 0.4. Molarity is equal to 0.4 molar. Now what we need, that is put this value in this equation, we will get the value volume strength. So what is volume strength here? That is volume strength will be equal to 11.2 into molarity is equal to 11.2 into 0.4, 10. Clear? Now multiply 11.2 by 4, 4 to the 8, 4 1 the 4, 44.8 divided by 10, that is 4.48 volume. This is the answer for this question. Okay, yes sir. So what is the answer? That is, you will find it, that is for this question A is the correct option. So in competitive examination they may ask such kind of question, because here the behavior of H2O2. H2O2 can act as an oxidizing agent. Yes, it can act as an oxidizing agent and can act as an reducing agent. Is it clear to you? Yes. Now I am going to rub this part and let's move to the next. Now let's move to the next one, 35. Now again I have taken this question from the chapter hydrogen and its compound, and this is again a calculative type question. 20 ml of H2O2 after acidification of dilute H2SO4. Again I am repeating, 20 ml of H2O2, right here, 20 ml of H2O2, okay, after acidification with dilute H2SO4, okay, that is when 20 ml of H2O2 react with H2SO4 on acidification with dilute H2SO4 after acidification, okay, require for okay, that is the, here is the acidified, that is acidified H2O2, okay, require KMNO4, that is there is a oxidation take place, okay, that means to say it act as a reducing agent, okay, and it act as a oxidizing agent. Clear? Now the reaction proceed. What is the quantity of KMNO4 is given? 30 ml of N/12, and as we know, what is given here, calculate the percentage of H2O2 in the solution. You have to find the percentage of H2O2 in the solution. It's very simple. As we know, when complete oxidation take place, then we will utilize the formula, that is, here the normality is suppose Nx. Nx into Vx is equal to 30 into N/12. Can you write like this? Yes. Or you can write write like this, 20 ml of Nx H2O2 solution. It will be exactly equal to, because complete oxidation take place, 30 ml of N/12 KMNO4. Nx into Vx is equal to 30 into N/12. Nx into Vx. What is the value of Vx? That is 20. Put here Nx is equal into 20 equal to 30 multiply N, that is put here 1/12. Am I right? Yes sir, you are absolutely right. Now Nx will be equal to 30/20 into 1/12. Am I right? Yes. Now this will cancel this one. 3 4s are 12, that is 1/8. This is the normality. Now what we need to find, that is volume strength here, that is normality multiply equivalent mass 1/8 into 17. Clear? Yes sir. Now what is the percentage? That is 8 to the 16, okay. 8/17 is equal to 8 to the 16, 1, 0, 8 1s are 8, 2, 8 2s are 16, 2.125. That is the value is 2.125. So what is the percentage of H2O2? Therefore, the percentage of H2O2 in the solution, that will be equal to 2.125 divided by 1000 multiplied by 100. This will give you 0.2125. Am I right? Yes, this is a simple concept. For this question, you will get the answer, that is 2.21. Here one thing, that is the method. Clear? Check it out. Now this is not 20 ml of H2O2 acidified reducing agent, it gives, so complete oxidation, so its value, that is 20 ml. Number of gram, what does it mean, my friend? As I discuss in volumetric analysis, number of gram equivalent. Actually, how do we write like this? Listen, we know normality is equal to number of gram equivalent, yes, upon volume of solution in liter. Number of gram equivalent of a reactant A will always be equal to the number of gram equivalent of B if the reaction take place, and here complete oxidation take place. So number of gram equivalent of A is equal to 20 ml of NX H2O2 solution equal to 30 ml of N by 12 KMnO4. Clear? Now what we get? N. And now this is the strength, not volume strength, pardon, this is a strength in gram per liter. Clear? Strength is equal to, that is normality. Again I am repeating how to find. Normality is equal to number of gram equivalent. Number of gram equivalent is equal to given mass upon equivalent mass upon volume multiply by 1000. If I take ml and if I take liter, write like this. Now what will happen? We will get N equal to VE into V. Clear, my friend? Then W upon V is equal to strength. Clear? Strength in gram per liter. Is it clear? So W upon V, strength equal to N into E. Clear, my friend? What is N? N is 1 by 8. What is equivalent mass? It is given here 17. So I have elaborated each and every step. Now percentage of H2O2 in the solution, you have got the answer. Clear, my friend? Yes, sir. So answer is 0.2125. This is a single option correct. Now I am going to rub this part and let's move to the next question. What is the next question? Check the thing. Yeah. Now matrix matching. Now I have taken this question from redox reaction. Now compound 1 and compound 2 is very simple. Tell me N2O5. What is the structure of N2O5? That is NOO like this. Okay. Then oxygen, then oxygen, then oxygen, and then oxygen. Am I right here? Tell me. Yes, sir. You are absolutely right. One mistake here. You cannot show like this, like this. This is a coordinate bond, my friend. Yes. This is a complete thing. Nitrogen contains 3 bonds, not 5. Now, what the thing? What is the oxidation state of nitrogen? Oxidation of the state of nitrogen 2x plus minus 2 into 5 is equal to 0. That is 2x minus 10 is equal to 0. 2x is equal to 10. And x is equal to 10 by 2, that will be equal to plus 5. Am I right? Yes, that is the second option. Now NaN3, okay, azide, that is sodium plus 1 and nitrogen 3 into x, 0. 3x is equal to minus 1, then x is equal to minus 1 by 3. What is the option here? That is third is the correct option. Clear? Now for NO, Nx plus minus 2 is equal to 0, x minus 2 is equal to 0, x is equal to plus 2. So for NO, in NO, non-oxidation state of nitrogen is plus 2, that is 4 is the correct option. N2H4 hydrazine, yes, NH2 and NH2. What is the formula here? 2x plus 1 into 4 is equal to 0. 2x minus 4 is equal to 0. X is equal to 4 by 2. Let me check once. Yeah, hydrogen plus 1, that is 2 to the 4 minus 2. X is equal to minus 2. So for this, that is A is the correct option. This is a multiple choice question. This is a simple question so that you can practice the oxidation state also. Now I am going to rub this part and let's move to the next question. What is the next question? Check the thing. Next question is question number 37. Again, this is a question from hydrogen and its compound, and it is again calculative based. Given here 100 ml of tap water containing Ca, calcium bicarbonate, was titrated with N by 50 SCl with methyl orange as indicator. If 30 ml of SCl were required, calculate the temporary hardness as part of CaCO3 per 10 to the power 6 part of water. Here is only 100 ml, that is 10 to the power 2 part. Clear? Yes. Now what to do? We know again the volumetric formula, that is 30 ml of n by 50 SCl will be just equal to 30 ml of n by 50 CaHCO3 whole twice is just equal to 30 ml of n by 50 CaCO3, because this is a standard equivalent to 100 ml of water. Now we can directly write that is mass of, now we can CaCO3 in 100 ml tap water. How to find the mass? We have the value of normality and volume. We know normality is equal to given mass upon equivalent mass upon volume multiply by 1000, and we have to find the value of given mass, that is N into E into V divided by 1000. What is the, write the formula, N into E into V divided by 1000. Clear? Yes sir. Now put the value. What is the normality? Normality is 1 by 50. Put the value 1 by 50. What is the equivalent mass? Tell me. 1 multi equivalent mass is equivalent mass of CaCO3. Yes. Equivalent mass of CaCO3, that will be equal to molecular mass 100 upon 2. Why 2? Because CaCO3 break like this, Ca2 plus and CO3 2 minus. Ion is 2. So 100 by 2, that will be equal to 50. So put here 1 into 50 into volume is 30 upon 1 by 50 into 1000. This will cancel this one, that is 0.03 gram. Clear? Yes sir. Therefore the hardness of water, what is the hardness of water? How will you find? Yes, hardness of water will be equal to 0.03 divided by what? Multiply by 10 to the power 6 divided by 100 into 100. This will cancel, this will cancel. What we get? 3 into 10 to the power 22, that is 300 ppm. Am I right? You are asking 10 to the power 6. So in 100 ml, or you can say 10 to the power 2 part, there is 0.0 like this. 100 part contain 0.03 gram. So 10 to the power 6 part will contain 0.03 multiplied 10 to the power 6 divided by 100. Now this point will move here and 100. So this will cancel this one. We will get 3 into 10 to the power 2. I have elaborated it, that is 300 pm. Clear? Yes sir. Now I am going to rub this part, my friend, and let's move to the next question. What is the next question? So for hydrogen and redox, actually in competitive examination they generally do not ask question from redox reaction, because there is a complete utilization of redox reaction in one of the most important chapter, that is in electrochemistry. In electrochemistry they ask the question, and basically electrochemistry is the heart of you can say generally they ask one or two questions, big questions in JEE Advanced examination. So redox serve the concept of this chapter can be utilized in the chapter electrochemistry, because all electrochemical reaction follow redox reaction. Okay, now in hydrogen and its compound, you have to focus hydrogen, and for advanced preparation for this chapter you have to focus on peroxide, all the theory, properties, chemical, physical reaction, and hardness. Sufficient for you, hardness of water. How to find the hardness of water? Method to find the method to remove the hardness of water, type of hardness, degree of hardness. These two topic is important for this chapter, for hydrogen and its compound. Clear, my friend? Yes sir. Now I am going to rub this part and let's move to the next question. Now what is question number 38? Again this is a numerical. There are 3 sample of H2O2. Okay, there are 3 sample of H2O2. Clear to you? Sample 1, sample 2 and sample 3. Sample 1 labeled as 10V, okay, that is 15V, and the third one is 20V. 10V, 15V and 20V. Half liter of each sample. Half liter and half liter, okay, of each sample are mixed and then diluted with equal volume of water. Calculate the volume strength of the resultant solution. 3 sample are mixed, so we'll write N1 V1 plus N2 V2 plus N3 V3. That will be equal to NRVR. Yes sir, completely true. Now volume strength we know. Volume strength will be equal to 5.6, that is 5.6, okay, 5.6 multiply normality. Clear? Yes. For first case the volume strength is 10. So N1 is equal to 10 upon 5.6. For second case N2 will be equal to 15 upon 5.6, and for third case N3 is equal to 20 upon 5.6. Clear? Yes. N1 is equal to 10 upon 5.6 and volume here is 1/2. N2 is equal to 15 upon 5.6 multiply by 1/2 plus 20 upon 5.6 multiply by 1/2 and NR multiply by 3. Why? Because equal volume. 1/2, 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 given here. Then diluted with equal volume of water. Yes, 3. So what is the value of NR? Now we have common. Yes, we can take 5 upon 11.2. Clear? Then we'll get 2 plus 3 plus 4 is equal to NR into 3. Okay, 5 upon 11.2 multiply 3 to 5 4 9 is equal to NR into 3. 3 3 is a 9. Now what we are getting, NR will be equal to 15 upon 11.2. Clear? This is resulting. Now what is the volume strength in the resulting mixture? That will be equal to 5.6 multiply by NR. 5.6 multiply by 15 divided by 11.2. This will cancel 2 times, this will cancel. So the volume strength we will find that is 7.5. Clear my friend? Yes, for this question we can say that is the volume strength is 7.5. So in competitive examination you have to focus on the basics theories, basic things. Now this is the end of today's lecture. Now I am not going to introduce more questions. In my next lecture I will discuss S block and P block element. Then after we will move towards the GOC, general organic chemistry, organic section. Clear? So focus on your preparation. If you have any doubt, come to our website www.misostudy.com, and in doubt clearing session you can ask, you can put your question, you can ask your question. Now my friend, time has come, time to say bye bye. Thank you so much.